So hello, welcome to my talk. My name is Marián, and I like to say that I love to integrate. I like connecting systems, also people, and it got so far that I even started writing a book about APIs and about integrating. And I don't know if you've tried to write a book, but soon I realized that it's really a lot of work. By now the book should have been finished, but there are still some delays, so we still need one chapter to finish, and the review process and the publishing company process. It takes a lot of time and it involves a lot of people. So sometimes I'm just thinking, okay, why did I actually start this? And then I had the answer that, in my experience on many projects, I've always focused on APIs and on integration stuff. And I realized that there are many places where mistakes can be made, and unfortunately APIs and integrations, by their very nature, if you design something not quite well at the beginning, it's very hard to change, because there are other components using your API. Sometimes they can be out of your control, or you don't even know what all the clients of your interface are. So maybe let's do this a little bit more interactive. So how many of you have experienced some nasty problems when you or your team implemented an API and made a mistake there? Okay, we've got quite some brave people here who can admit this. And second question, how many of you have experienced serious problems caused by some third-party API that you had to use or work with? Yeah, at least the same number. In other events where I did this talk, it was usually much higher number. And I like to say that it's always the other ones who make the mistakes, not us. And it's because the people who come to meetups are usually the smart ones who know how to prevent problems, but you never know. And maybe thanks to this talk, this information will be more explicit, and there will be some ways to share it also outside of this room, and also these third parties will learn how to do things better. And here's this QR code. I mentioned that I'm writing a book, but not just that. My interest in integrations is broader, and originally I collected a few people to give me some ideas for the book, so that when I'm already putting the effort into the book, so that it makes sense and so that it's useful. But still, actually, I can get inspired even in this very late stage of the book. But not just that, I always have more content. I always learn something new, either from my professional work on projects or from various conferences or whatever. And this is why I created this mailing list where you can register using that link here. And so firstly you can get some free stuff. So you can get some samples from the book as it is in the draft version. Later, when we finally get to the point that the book is complete, then I expect there to be some opportunity to get some discounts, maybe even some free copies. I don't know exactly, but this is why I created this, so that I can inform the people who are really interested. And yeah, as I said, I share also stuff that is out of the scope of this book. So that's why. Okay, now before I go to the first slide, I prepared a small psychological experiment, and that experiment is that I will say something, and you will focus on what it triggers in your mind, and then I will ask something. So, and the thing I'm going to say is API. Yeah, very simple. And now, how many of you, when I said API, started thinking about a REST API? Okay, almost the half. So this is a proof of my psychological hypothesis that REST APIs are fairly popular. Why is it so? Well, because World Wide Web is everywhere, and even though there were many different ways of integrating before, with the web, the new protocols became very ubiquitous, and basically the HTTP and web services became like something like a common language, lingua franca, that almost everybody in the IT industry has to understand and support in some way, which is great. Yeah, we have also had another web services standard, the so-called SOAP web services. Unfortunately, the guys who designed those certain web services missed one principle, which is called KISS, keep it simple, stupid. So they were basically duplicating stuff that is already present in the HTTP protocol and making things more complicated than necessary. Now with the REST, it was much easier to do almost the same stuff. But just because REST is so popular and and you can do so many things with it, doesn't mean that it's always the best choice. So that's the first thing to bear in mind. Just because you automatically think of a REST API when you want to integrate something, that doesn't mean that it's the optimal choice for your use case. So that's why it's also important to know about the alternatives. And we are at a Java meetup, so most of us are probably Java programmers or developers, and a programmer usually needs to connect two things, or one thing with several other counterparts. And actually a programmer just wants to invoke a method or a procedure. The only problem is that that procedure is running on a different machine, and that's it. Well, and this kind of integration is called RPC, Remote Procedure Call. So if you know that you can control all the communicating parts, or you can assume that they will be able to use your preferred technology, then probably RPC is what you need. And if you don't need to do a lot of backwards compatibility and be very open for extensions, then you can, for example, use gRPC, which is very nice technology, and you don't have to care about protocols and headers and all this stuff that are not important usually. And also you get automatically some bonus, like an efficient encoding, some binary encoding of your data. So that's one option. Another thing that where we usually use integrations is when we have a microservices architecture, or generally when we connect some systems within one company, within one organization, and that it's quite common that the number of components that are connected can be quite large, and they can be managed by different teams, or there can be other requirements, like we want to make sure that the communication is works even if the speed at which one component communicates is much higher than the other one, and things like that. And for that, there's a great way to decouple those parts, and that's using some messaging kind of integrations. So stuff like Kafka, JMS, or some maybe in the cloud you have some queuing systems that gives you loose coupling and also possibilities of streaming and basically not depend on having everything available at the same time, so being synchronous. Of course, nothing is for free, so messaging is asynchronous, and asynchronous programming or communication style is more complex to think about than synchronous. So that's something that you need to be aware of. Of course, you also have to somehow manage that messaging infrastructure. So those are things that are easier to do when you are within one organization. Then third example that I have here is GraphQL, which is quite commonly used as an alternative to REST APIs. GraphQL is interesting in that it offers you a query language. That's why it's QL. And the advantage of it is that you can you don't have to know what exactly which attributes and what combination of attributes of different entities you will need to work with on your API. So you just throw GraphQL at it, and you have all the possibilities available. Well, that sounds nice, but in my opinion, usually the need for GraphQL can indicate that it's not that REST API is insufficient for your use case. It can be a smell of a lack of business analysis, because you don't actually know what you will need to query or what you will need to update and in what combinations. So why is it so? And another thing is, when you have a large variety of options, that's usually also used. So the clients will probably contain some logic that will somehow do some complex stuff to generate some GraphQL queries. And if you have multiple clients, then some of that logic will probably be duplicated across those clients. And maybe a better idea from the architectural point of view would be to put that shared logic on the server and protect it there, not put it on the client. But of course, you need to know your use cases. Okay, but let's assume we do want to use REST, and every technology that you want to use or every specification you want to use, you should do it well. And that means you should know the principles and understand why they are there, not just take some example or some tutorial and blindly follow it and say, okay, this is it, this is how it should be. So I have an example here, which is a very popular example of a REST API. It's called Pet Store at Swagger, on the Swagger webpage. That's quite nice, but let's take a little closer look. Here we have a HTTP put, and the payload contains an ID attribute. And now let's think, okay, why is it correct? Why is it actually so? I think this usually occurs because programmers are very keen on reusing things. We want to abstract everything and do not repeat ourselves. So probably there is also a post endpoint that creates a new pet, and as a response to that post endpoint, we want to return that newly created pet, including its ID that was generated. And when we already have that structure, of course, we can reuse it here and have it also for the put endpoint. But now the question comes, what is a URL? That's a acronym that all of us hear every day, and we don't even realize what it is. It means Uniform Resource Locator, which means it defines how the browser or any other HTTP client should find where and how to contact a server and access some resource on that server, some file or some program. But what we should also know, that URL is one of the two possible types of a URI. And URI means Uniform Resource Identifier. So URL is not only does not only specify how to reach to something, it should also be a unique identifier of that thing that we work with. And that's why when I work with a pet, my URL should identify that pet. But when I put it in the payload, then I don't need it in the URL, which is not very good because I might, usually when I put something, I also want to get it, for example, and for the get, I already need to put that ID into the URL. So I have an inconsistency that I use a different URL for put than I use for get. And of course, I can also have a get without any ID to get all the pets, for example. But it would be really strange to have a put endpoint which could override all the pets in one request. That's not probably what we want. So, yeah, to sum it up, we should understand what we are using and what are the principles and best practices, so that we have like a good resource structure. Resource is what the URL is identifying. And okay, when I'm already talking about resources and the path in the URL, I will talk a little bit about naming. And I must say that the REST standard or architectural style doesn't actually prescribe any naming. But again, if you take a Java program, you could rename all your variables to A1, A2, A3, and the program would work as before, but of course it wouldn't be very maintainable. It would be basically obfuscated. And the same goes for APIs. So that's why there are many guidelines or recommendations how to structure and name your resources. We usually try to create some hierarchical structure that's similar to a directory tree. And one of the rules is that the name of the resource should be known. But sometimes we feel the need to put a verb in there. But that's not correct in my opinion, because the verb is already here in the HTTP method. So a sentence containing two verbs doesn't make sense. Usually this can be fixed very easily, because if I want to approve an order, I can say that I'm actually putting an approval, which is already a noun. Or if I can even group the approve and cancel and generalize it into that I'm setting a status for the order. And also the advantage of using English for naming things is that many verbs can be also a noun without any change. For example, the order itself can be a verb and it can be also a noun. But I don't want to sound like I'm very dogmatic about the rules and principles and stuff. I just want to say that you should use the rules or requirements where it's not too hard and when it can bring you something back. But if abiding to a rule is very costly, very complicated, and you don't get so much from it, of course, in our projects we want to deliver some value to our customers, so we need to be also pragmatic. And one demonstration of a pragmatic approach to REST APIs is something called a Richardson maturity model, and that says that this maturity model has some levels which say okay, when you do this, you are at some level of REST, fulfilling the REST standard. And most REST APIs that I've seen don't fulfill all these levels, especially the highest one, which requires this thing that I don't know how to pronounce, but it means hypertext as the engine of application state. And it basically means that your APIs should be like a web page, which means, okay, if you want to go to, for example, Google, you just type google.com. That's you just need one URL, and then something will be displayed on the page, and then you will type something into a form or click on some link. Another page will be displayed, then you click again, and so the hypertext or hypermedia guides you through all the operations that you can do with that server. This is quite ambitious. Of course, the browsers can do that because they have standardized HTML, so they know what to do with the HTML, and of course the client is many times a human, so you know how to, that if something is blue, that you should probably click on it because it's a link or some other things. But of course there are also some websites where it's not so obvious and even a human can get lost. So implementing this HTOS is usually quite complex for some simple client. And in practice, what we really need is, we do want that the client somehow gets some information about that API or that server, what can be done with that. And usually instead of doing this hypertext stuff, we use specifications based on some standard language, and that standard language, usually currently the most popular one is OpenAPI. So let's take a look at how we can tell the client, or not just the client, but anyone interested about our API, how we can document our APIs in a formal way and standard way. OpenAPI, okay, I'm not going to explain to you the whole syntax. You can study it somewhere, but basically it's some language that can be expressed either in JSON or YAML, and now the question is how do I get this OpenAPI specification? When implementing APIs, there are two main approaches. The first one is called code first, which means I'm writing a code and in some implementation language, for example Java, and from that code I can generate the OpenAPI because I'm a Java programmer, so Java is what I'm good at. I don't want to bother with some OpenAPI, so I have some libraries, some tools that can generate the OpenAPI for me. Well, that's nice and quick, at least from the start, but it also has some drawbacks. Mainly, basically, to me, an API is similar to object-oriented programming. In Java, we have classes, and some of the elements of the class are public, and some of them are private. And we know why it is so. It's because we only want to make public something that's really needed to communicate with the outer world, and by making all the rest private, we are protecting it so that we can change it without affecting the rest of our program. So, would you write a Java class with all members public? Maybe you would if you need to do some quick prototype or something that is just used once and you want to have it quick and easy. But for some serious stuff, you usually don't do it. And if we do it for Java class, that's where the API is reachable from within one program, we should be even more cautious about APIs, REST APIs that can be reached from, in theory, from the whole world. So the problem with the code-first approach is that every time we make a change in our code, in our implementation, some new open API is generated from that, and sometimes we don't know what the open API actually contains, and if we want to be in control, then we still need to actually understand open API, and we need to think, okay, if I do this, what will appear in the open API, or does actually all that I have in here in my class, does that all of that should be in the open API, or just some parts of it? And another problem is that the specification that gets into the open API is actually spread across many places, because I have some annotations here, then I have some models, data models that I use for the request body or response body that are in a different class. Then, and even more, okay, I can show an example. Sometimes even that is not enough, and I need to really add some metadata so that I have like a really nice open API from that. So basically I use some Java class that's not actually related to Java. It's basically modeling the open API syntax and just adding some information so that I have what I need. So that's why I think for a long term it is usually good to invest in a specification first approach, which means that okay, it's very small, but basically I start from the open API specification. Okay, I need to learn it, but then I can use some generator, and that generator always generates the fresh Java code from it, all the models and stubs of my controllers. So now when I compile it, it runs an open API generator, and now I get an error because I intentionally changed something in my specification, and it doesn't match my implementation of that endpoint. And that's a good thing, because that's why we are using Java, that it's a statically typed language, and if something doesn't match, we get early warning. Not we don't we learn about it before it start the program starts or it's deployed to production or whatever. So now if I fix it, I don't remember what I broke actually. I know. I changed the product ID. This product ID, I changed it to number, and before it was a string, like this. So now I can regenerate very quickly again. And the error is gone because I have a string here. Okay, back to the slides. When I'm already talking about Open API and being, it basically another advantage of Open API is that it's language agnostic. So yeah, you need to learn another language, but then if somebody uses Python and wants to consume your API, it's not a problem because Open API is agnostic. So you don't force everybody to use Java. And another thing is not just Java or any other language. For implementing APIs, we usually use some kind of a framework. And these frameworks usually are like a new version of Hello World program, because if you learn a language, usually the first thing you do, you write some Hello World program that just prints Hello World. And with frameworks, usually the first thing you do, you write a few lines of code and you start it and you have an API that brings something, I don't know, maybe Hello World or something as a response, and it looks very easy. So then we start implementing our stuff, and before you know it, you are logged in because or you have framework-specific code everywhere in your application. But these frameworks, they are also changing, and new frameworks are coming. So I remember the time where there was Java 2 EE, or just Java EE. Then, of course, some people said we don't want application servers. We want standalone applications, just like a jar file that you can start immediately. So Spring Boot was born. Before that, of course, we had Spring Framework, which also had some advantages comparing to early Java EE versions. Then, of course, we started using containers and cloud, and suddenly we started thinking about how fast can the application start and how much memory does it consume, because it's money and it's needed for scaling and for failover. So we started trying to put more work into the build time, so that in runtime at startup we don't have to do so much. And we got new frameworks like Quarkus, Micronaut, or we do native compilation. But how can a normal developer cope with this? Okay, I have one. I have started an application with one framework. Now there are many others, and maybe other teams are using other frameworks, or there are new versions of the framework, and I need to migrate. And suddenly it's not Java X, instead I have to write Jakarta, and what do I do? So yeah, sometimes not all, we need to slow down a little bit and concentrate on the things that don't change so quickly, and that somehow prevent the whole community, the developer community, from fragmenting. And those things are maybe don't sound very sexy, but they are really useful. Those things are called standards. So Java EE actually, from very early times of Java, was a standard which enabled different application servers like WebSphere, JBoss, WebLogic, whatever, to run very similar code, because there was a standard APIs that allowed that to work. Then we got Spring Boot, which does things. It actually builds also on Java EE, but it hides it a little bit. But partially, you also use Java EE, like for example for PIN validation and for transactional annotations and other stuff. But you also have used some Spring specific stuff. And now, okay, somebody says, okay, now we want to use Quarkus instead of Spring Boot. What do we do? So again, we should think about, okay, is there a standard that we can use? And now the Java EE standard, it's owned by the Eclipse Foundation, and it's vendor neutral, so it's not just Oracle or just one company. There are many companies that need to cooperate on that to agree on some standard. And under the hood of Jakarta, there's still this Jakarta EE, like the big standard, but there's also a smaller standard called microprofile, or actually it's not a subset. It's like there are two standards that have some overlap. This overlap is called the core profile. But yeah, usually the core profile is actually what is the most important for your application. So for example, in REST APIs, you use you need to when I was showing the Spring Boot implementation, we use a controller, but a very similar thing can be done with microprofile. So instead of yeah, you can see there are also very similar. The structure is very similar. Just the annotations are a little bit different. So that's why I recommend to concentrate on either Jakarta EE or microprofile, so that you have some standard. And if some new framework comes with some new stuff, it's great, but you should think maybe sometimes limiting yourself to just the standard stuff will protect you from locking into that framework. Actually, I tried it myself because I knew that both Quarkus and Helidon fully support the microprofile standard. So I said, okay, let's do it. And I started implementing an API for the book in Quarkus. And then I took the same code and wanted to migrate it to Helidon, and suddenly it didn't work. And then I realized that in the guide that I used from the Quarkus website, I was using some stuff that was Quarkus specific. So instead of this Jakarta something, like for example path param, or some is for some also for dependency injection and so on. I used some specific implementation that worked in Quarkus, but it didn't work in Helidon. So again, it's important to notice such small details, because then they can save you problems in the future. Okay. I said that writing an API in a framework is usually very easy. You can either generate it from OpenAPI, or you can write some code with some annotations, and it's very easy and it works. And also we have the support of the framework in other areas, in other layers. For example, the persistence. So we can use some JPA, or some other object mapping, object relational mapping, or some other models that give us very easy access to some databases. But sometimes it's also, or sometimes always, it's very important to also think about separating things and to have a good architecture of our application. Something like the hexagonal architecture or ports and adapters. Doesn't have to be totally that, but you should be aware of the different layers of your application. And this is why it's recommended to use so-called DTOs, or data transfer objects, in your APIs. And you may think, okay, why? Because I can take my database entity model and put it directly into my controller, and it works. But I once saw a very ugly example in some project where we, for just to save time, we did it this way, and suddenly then there was a strange problem. There was some mismatch between the schema in the database and the entity, and we started getting SQL exceptions. But these SQL exceptions appeared as JSON serialization exceptions, actually. And why is it so? Because by default, Hibernate does lazy loading. So if I have an entity and it has some child entities, so one-to-many mapping, and I select the user, these transactions of the user are not loaded automatically or eagerly, only when asked. And now, now my service that I used, it selected the user, and only when the controller tried to serialize that user into JSON, it called the proxy method that fetched these child entities, and there was this SQL problem. So now I got some exception at a place where I didn't expect it. So my error handling didn't work as it was expected, and this is just a very edge case or very unusual situation, but it's just something to demonstrate that really this is not a good place to be. So it pays off to use some data transfer objects to separate your layers. And of course we have some helper tools like Mapstruct, for example, that can do the mapping for you. So why not do it? Okay, another thing is, again, we programmers like to reuse, we like to share, create libraries and things like that. So when I was showing you how I can generate the API classes from an open API specification. Okay, so when I'm already deep into that generator stuff, and I know how to what Maven dependency or Maven plugin I need to use, and what version, and how to configure it. So when I already know how to generate the code for my server, why not do also already generate also the client in the same project and publish it as a library? It seems like a good idea, but actually we need to think that quite commonly the reason why we need APIs, or why we use APIs, is that we want to separate things. We want to decouple things. So we want to have separate systems or separate services that can be deployed independently, that can be developed by separate teams, and so on. And now actually by creating a client jar, client library, or SDK, or whatever you call it, we are creating coupling, because that client needs to depend on what we provide. They have to use the same transitive dependencies, they have to use the same version, sometimes they even have to use the same configuration, like timeouts or retries or whatever we have in that library, and they might not want that. And again, yeah, there might be clients that use a completely different language, and of course they won't like it if they get a Java jar, right? Another thing where we can think about the reuse in the context of APIs is, okay, we agree that we want to use Open API because it's agnostic, it's compact, but even in Open API there might be some structures that we want to reuse. And okay, how do we do that? Or should we do that actually? And that's again a risky thing, because again we create some kind of a coupling. So by saving something, or some duplicity, we are creating some coupling. So from different sources I have this opinion that it's usually not worth it. And if you want to reuse, then you should reuse things that don't change. So, and one good example of a thing that usually doesn't change is that the structure that we commonly need for reporting error states. So, when something is not good, we want to say, okay, there's an error, and we want to provide maybe some details and maybe some code or some additional information. Of course, not too much, because that can be a security risk. So we need to think about what we want to put into that error detail, but we want to have like something consistent. That's not a bad idea. And the good news is we don't have to reinvent the wheel. We don't have to make up our own structure, because there's already an RFC, so an internet standard for that, which defines a schema where that should be satisfactory for most of the error cases. I once got a question if that different endpoints or different services might have different needs for errors. And now my new idea that I got about it is maybe if we really think about it deeply, or what we could do is we could distinguish between business error and technical error, because we could have a situation like I don't have money on my account, and so if I send a request to transfer money from that account, of course I get an error, but that's a business error because that's something that the business expects. And for that case, it may make sense to create my own schema because I want to provide my business specific information in that error response. But every time I need to also expect some technical errors, like some communication doesn't work or I'm out of disk space or whatever. And these are usually, you cannot predict all of them. That's why, again, for the technical errors, it's usually good to have such a generic structure where you can say what happened. And of course, you should use the correct HTTP code, status code. I will come to that later. And it's here. So so this is again RFC. So RFCs are a great source of standards, but the most important RFC, of course, if you are doing REST APIs, the RFC that defines the HTTP protocol. I don't remember the latest number of the RFC, but you will be able to find it. And of course, at least you should understand the basic stuff, which is like the status codes. So returning a 200 when it's actually an error, what can be wrong here? It's quite, this can mislead the client because the clients may ignore your body that you return, and it sees, okay, it's 200, so it's okay. I can drop the data, it's already saved, and it's not saved, right? Another nasty thing is when you there is something wrong with the request, and you return a 500. So now the client thinks, okay, something doesn't work. Okay, so I'll try again, and it will try again and again and again, and it will bring down your network and your service. And the only thing that you actually should do is not to return 500, but instead you should return 400 because the request doesn't have a chance of succeeding. Okay. I don't actually remember why I put these examples here, but there are many HTTP status codes, and it's good to know them. And another thing is here is it's. I say that you should be KISS, right? You should try to make things simple and not over-engineer them. But sometimes you can do just a little bit of over-engineering. That won't cost you a lot, and it can save you in the future. And one such example is if you are using JSON, like most current REST APIs use, and you return a collection of items. Of course, the default would be to return a JSON list or array, but you should understand that it's quite common that the number of the items that you return may be also large, and then you might need a pagination, or maybe you need some other metadata with the response, and now you don't have a place to put it in a backwards compatible way. So that's why it's usually good to wrap this list of items into a JSON object, so that you have a place to put such stuff in. Okay, I mentioned backwards compatibility, and now this is also a very important topic, because almost every API needs to evolve and needs to be changed, and of course we need to be prepared for that, and we should have some strategy for it. And I think the most important question that we should answer as soon as possible is, what is actually a breaking change for us? Because it's not as easy as it might seem. For example, very typical thing, we usually usually think that when we put some optional field somewhere, when you edit, that it's a backwards compatible change. But are you really sure? Because there can be clients who are so strict that if you return a response with some additional field, that they will break because they don't know what to do with that field. Another example is you might have a bug and a bug fix. If you use a semantic versioning, like you have version 1.2.3, now when you fix a bug, you have a version 1.2.4, which means it's a very small change. Basically, your schema is as it was, but it doesn't always have to be a backwards compatible change, because there might be a client that already developed some workaround for your bug. Now, when you fix the bug, you actually break that client. So, again, yeah, it depends. And now we can also have an opposite situation, that, for example, we use our API for communicating between the front end and the back end. And we have a full stack team of developers. So we have both the client and the server under our control. We are able to synchronize the deployments. So actually, even if we do a breaking change, it might not be a breaking change in our situation, because we make the two changes at the same time, and it works. So we can save a lot of complications, and we don't need to jump to version 2 and supporting multiple versions and so on, because that's very complicated and costly. Okay, sometimes we know that there's a breaking change. Now, how do we prepare? There are many guidelines that will say, okay, just every time you create an API, just put v1 into that path, and you will be prepared for new versions. But it's not that simple, because now if you need to change something in your API, you usually don't change all the endpoints and all the resources. You usually just need to change some of them, or maybe just one. Now, what do? Do you copy the whole hierarchical structure of your resources under v2? Yeah, then That might be a lot, of duplication, and also this way your version number will grow quite quickly. So soon you will be maybe version 53, and I don't know how many versions you can afford to support at the same time. So okay. Another thing would be, okay, so I don't put the version at the beginning, I can put it somewhere towards the end. Now, is it okay to put it after the ID? Maybe, but again, will it not confuse the clients that some resources are under version 1 and some have version 2? What if they want to use relative URLs? That won't work for them. So yeah, these are all the things that you need to consider, and of course the best way if you can avoid the breaking changes, right? But again, sometimes you can go too far with it as well. Yeah, do like this. Sometimes you can see, like this is an example of an anti-pattern that's called schema inside a schema, or yeah. So we can see this is XML, but inside that XML we have another XML, but that XML is an XML in disguise. It pretends to be a string, and that's why it has to be escaped. So instead of left bracket we have end LT and so on. So yeah, firstly it's unreadable, but what's more important, usually why this actually happens, it usually happens when the developers for some reason can't, or they just too badly try to avoid changing the schema. So they invent their own schema and they put it inside that schema that is like unchangeable, but that doesn't actually solve the problem, because it can even make it worse, because then usually this inner schema is nowhere documented, or there can be even some syntax errors with it. For example, this XML prologue with the encoding is probably lying to you because it's already embedded into something, so it's probably not relevant. So sometimes it's maybe better to have a breaking change than really avoiding it at all costs. Another way how developers can try to avoid breaking changes is using a key value pair structure. So I don't know if my address will consist of first name, surname, street, city, I don't know what. So I will just put key value and I put it into an array. Great. Okay, my schema will never break, but again, it's just postponing the problem. To me, this is again, I mentioned that Java is great because it's a statically typed language, and the difference between Java and JavaScript is that JavaScript is a dynamically typed language. So in JavaScript, if you assign a number somewhere and then in the same place you assign an object, it somehow works until it doesn't work, right? So and this
at runtime.
Yeah, you discover it in runtime, and maybe sometimes you discover it in a totally different module where you don't expect it. So, and the same thing goes for the APIs, that you have two services that communicate, and that now one service uses a key value pair structure, and then it decides, okay, now instead of city, I will put I will separate or I will separate the street into street and number. So I will create 2 items instead of 1, but I won't tell anyone. So the other service will still expect that it's just one item. Everything seems fine. Just the data will be lost or inconsistent. So again, sometimes I think sometimes it's actually good. The breaking changes may be good as a feedback to the business people, because if business people can't tell what the structure of the data actually is, that means that the analysis is not complete. And now, if I create a static structure from what I know, and then I need to create a breaking change because suddenly the business realizes it should be different, then of course it's costly, but at least they know what they learn something from it. So again, we technical people shouldn't always try to fix all the problems of the business people, because then at last it's not always possible. And this is the last slide about testing, which is of course also very important. And the best thing is the test-driven development. So you develop tests first, and only after that you implement your functionality. And now, how is it with APIs? Many organizations or projects define some test coverage ratio. You have Sonalake or something, and every time you add something and you don't cover it by unit tests, it shouts at you and blocks your pull request because you don't have, I don't know, 80% or something. But sometimes it's too simplistic, this approach. There's something called the test pyramid, which says that yes, these unit tests are at the base of the pyramid, so we should have a lot of them, and yeah, they are great because they are very fast and so on. But for APIs, usually, it's something that's just some boilerplate code, or it's something when there's a problem with it, it's usually not what the unit tests are able to test, because there can be problem with authentication, there can be problem with serialization, or some headers missing or whatever, and these things are usually abstracted away, and so the unit tests are just to satisfy some ratio. So in my opinion, it's better to exclude the API layer from the unit test coverage ratio requirements, and it's where we should invest that time is to create some integration tests that the best where we really test the real thing. So we start the whole application, and we really send a real HTTP requests to it and check the responses, because then we are sure that it really works as expected. And there are some tools that can help us for that, like for example REST Assured is a great library to generate test HTTP requests. Test Containers is a great library or great platform actually to run the different dependencies that your application needs to run, like database, messaging or some other services, some other APIs that you need to mock. So there are ways to do it better. Okay, so again, this is the link to my club of integration lovers. And before I get to the questions and answers, there's one more thing. Last time at this meetup, I had a talk about how Kotlin can be useful to Java developers. So for those who weren't here or who would be interested in this topic, basically the main point of the talk is this girl that doesn't want to eat some healthy food because she says I don't like it, I don't want to eat it, and but she doesn't even try it. So the point is you shouldn't say that Kotlin is not for you if you didn't try it. So that's again and by the way, I'm doing this talk again next week in Brno, the Brno Java user group. So in case you are there, you can join, or it will be also streamed on I think YouTube or somewhere. So yeah, you can see that as well. Okay, so thank you, and if there are any questions, either you can ask now or you can do it with beer in your hand or pizza in your mouth.
Yeah. Do you think that APIs and versioning in the content type could solve the versioning problem?
Yes, there are two things. Okay, versioning in the header is a good idea, irrespective of the other stuff. Yeah, that's what I forgot to mention that instead of fighting if V1 or V2 should be at the beginning of your path or at the end, there's a way to do it. With headers, and there's also a standard way to do it with content type, which is a standard HTTP header, and it's not exactly HTOS, but it is, I would say, more RESTful. So you are embracing the HTTP standard instead of fighting with it by putting some artificial things in your URL. So yeah, I would definitely recommend using the content type as for versioning. Another thing is that you can also approach it from a business analysis perspective. That means if something changes in your structure of your entities, sometimes it's good to go one step back and ask, okay, but is it actually still the same thing from the business perspective? Maybe it's something new. So in that case, we might need to add a new resource with a new name, and then the problem is solved. But if not, then of course we need to do some kind of versioning. So yeah. So I would say use the headers. It's good. It's not bad.
What do you think about the JSON API standard?
JSON API. I don't know exactly what it is. Actually, I think. But yeah, there might be. Can you maybe tell me something about it?
There's a standard about how JSON structure should look like when you call get. So there's like structure in the root. You have some metadata and then data and so on. There's structure, but it has its disadvantages. So therefore, I asked you maybe some opinion about it. Because let's say on our project we started a JSON API and standard, and then we moved away because it has limitations where we have to use our creativity. So that then is no reason why it is the standard when you cannot follow it strictly.
Yeah, I don't want to say that I'm the biggest guru on everything connected to APIs, but yes, I didn't know that this standard, and for every standard that is not so widespread, you should be a little bit cautious, and because exactly also there are not so many resources on, there's not so much experience with it, and there are not so many resources where you can get some advice how to use it properly. So yeah, sometimes, but it's like with the frameworks. Sometimes something can look like very, very cool, very, very nice, but it's not so many people use it, and then you are stuck because now you don't know if you are using it correctly, and it's hard to get away from it because so yeah, there are definitely different guidelines. Like there is a site with different guidelines from, for example, from Microsoft, from Google, and other companies. So that's probably not bad thing, because these big companies, they have a lot of APIs, and they already have some experience, and they know what works and what can be problematic. But yeah, like with everything should be a tool that serves you, and you shouldn't get into a situation that you are the one who serves some tool or some standard.
My question comes from the curiosity. I heard a lot about gRPC, and like it was interesting for me to test it and compare to the REST, because I'm already familiar to the REST. And I created 2 microservices. One was like RESTful, and I decided to provide like all CRUD operations for one entity, for instance. And I do the same for the gRPC, and I heard a lot that gRPC uses this binary encoding that REST doesn't, and that's why it should be like faster. And when I tested it with the Postman, it turned out that REST still like faster than gRPC. Maybe you are aware about the details. Like I saw that really first request to the not warm up like Spring Boot application took like it was the longest request. But when I retried the same request like several times, it was like faster and faster, like I don't know, 4 times. And maybe you're aware about like some caching, because I tried to like find the reason why REST is still faster than gRPC, even though it uses this binary encoding, but I didn't manage to understand.
It really depends on size.
On size of the body, yeah.
It's incredibly different between Jackson and Google J library for JSON. It can be incredibly different in this speed. It depends on the size of objects. For small objects, it can be incredibly speedy, and for large, it can be incredibly slow. That is from life experience.
Actually, I don't have so much experience with gRPC, but it's a great topic in general. Performance is a very complicated topic, and there are very many factors that contribute to the performance. Even the what you are measuring, what's important for you can be very different. For someone, the throughput is more important. For someone, the response time. For someone, it's when I fire the first request. For someone, if I fire, I don't know, it's not a problem if the warm up takes some time. So actually, in that book that I'm writing, that's one of the chapters that I was like fully responsible for, is about performance. And there I also write that usually the design and thinking about what you really need is more important than the actual implementation, because, like, for example, if you have a large binary data that you need to transfer, and you put that data inside a JSON, so you need to do a base 64 encoding or something like that, then of course it's inefficient. So you need to think what you're actually doing, and also like this, as you said, that it got faster and faster. That's typical also in general for Java applications if they are running on the hotspot or JIT JVM. That when you perform more and more operations on the application, it gets optimized. It gets compiled into native code gradually, and then it's fast, and it can be faster than an application that is compiled ahead of time. But the startup time can be longer. So it's always, there are many trade-offs. Yeah, but sorry, you wanted to say also something or not?
Also, you don't know in several especially there can be caching you are not aware of. So if you are doing some testing, I always recommend doing some randomizing in the request.
Yeah, that's also, yeah. If your benchmark was correct, yeah. If it was really representative of what your application would in fact do, because if you send the same data a million times, it's not what you would do in reality. So
yeah, that's true. Thanks.
Okay, so I invite you now maybe to
Yeah.
continue in the chat over the pizza.
Yeah.
because-
Okay.
So you have
Thank
time
you.
for like
Thanks a lot. Thank you.